Okay. So what do we do if we have missing values? Okay. Now, even if suppose if you reject, okay, if in a given row, if there is a missing value, I'm going to throw that row out. Okay, you can do that. You see a missing value, well, there is a missing value, throw it out. Right? Now we can mathematically show that even if you have only 5% of missing values, around everywhere, you can very well, in some cases, you may very well end up throwing 80% of the data out. You end up with just 20% of the rows with you. So often, throwing the missing values out is not a good strategy. Okay. But if you want to do it, if there are not very many missing values, so you don't want to mess with handling the missing value, you can throw them out. So you can use drop NA. So drop any rows with missing data, you might end up losing a lot of data, not a very good strategy. Okay? But if you want to do it that way, then we can do that. So here we go back to DF2. So if DF, how many rows did we have in DF2 early on? I mean, originally DF2, let's do DF2 has 13 rows. Let's do an info. So there are 13 rows. And if you use drop NA, you end up throwing out 10 rows, and you end up with only 3 left. Okay, and there are some variations in drop NA. You can, the default is any. How equal to any means if you have any missing value, even one missing value, then gone. So that is how equal to any. How equal to any, as I said, is default. Now, if you say all, so that means all all the values in a row must be missing, then only you drop. In that case, you don't drop any at all here. And then you can have a threshold. Now, threshold is not how many missing values there are. Threshold is how many good values there are, I think. Thresh is number of non-missing needed. How many non-missing you need to keep it. Okay. So here, if you say 4, then if you have 4 good values, then you keep. Otherwise, okay, so if you make that, you need 5 good values, then you see that you start throwing out even more and more. And of course, if you say, if you increase, if you decrease thresh, then you end up keeping most of it. Smaller value means less number of thrown out rows. Okay. Now you can do the same the other way around. Okay, in each column. So x is equal to 1, then a column is thrown out. So here V1, V2, V3, V4, V5. So if we increase thresh to 9, so now V3 is gone. So when I increase the thresh for axis 1, then it's column wise you get rid of a column with too many missing or too few good values. And you can target it to a particular column as well. So if you want to just look at one column, this is a critical column, and in that column, if you have an NA, you want to throw it out, then we can say, okay, so DF2 and you use not NA. So suppose that V5 is the target column. Okay, target is the Y column, and you can't have any missing values there. If there is missing value, then it's of no use. Okay. So if you want to look at that column, drop any row that has a missing value for V5, right? So V5 has two missing values. And if V5 is the target, okay, remember the term target, it's an important terminology. So that's the dependent variable that we are trying to predict. If that has missing value, then those rows are of no use to us. So you can use a mask that's about that particular column, and again, not NA is NA true means it is missing, false means it is not missing, right? Not NA is the opposite. Okay. Not NA is true if it is a good value. Is false if it is not. If it is an NA, then not NA is false. So the NA values will come in as false. So you can use that as a mask to filter out. So if you say DF2 and then you put that code, so all the true rows will be kept and all the false rows will be thrown out. So you see that 3 and 4 are gone. Index 3 and 4 are gone in here. Okay. So if your strategy is to throw out rows with missing values, you'll use drop NA. And you can use drop NA for each row, looking at the values in each columns of a row, or you can do it column wise. You can use a thresh, okay, to indicate how many good values you need. Okay. And you can throw rows out by looking at just one column. Okay. So that's what you've seen so far with drop NA. Okay, so here we go back to DFQ2. If rows with at least one missing value are dropped, how many rows will be dropped? Okay. Okay, so DFQ2 drop NA. So that's going to drop all the missing values, right? But you don't want to count how many are getting dropped. So here 160 rows remain, and I think it was 299 or something, originally, right? Well, we can use the length. So when you drop NA and you count the length, so that gives you 160. So how many did we drop? Well, we can do a length of DFQ2 and then subtract the length of the data frame after dropping NA. So this is the original number of rows, LEN DFQ2, and this part is the length of the data frame after we have dropped. So the balance tells us how many rows did we drop. Okay? Is that good, everybody? All right. How many rows will be dropped if only rows with all missing values are dropped. So it's the same thing, except, okay, so I'm going to copy paste that one. Okay. But in drop NA, we have to use what? Have equal to all. Okay, so nothing gets dropped. Okay. Now C, is B okay, everybody? So how many rows will be dropped if rows containing half or more are missing? So we want to use thresh, or you can use proportion. Okay, there is more than one way to skin this cat. So, well, let's take, so we are looking at the rows, so half of them should be missing. So if we do length of DFQ2 columns, okay, so that's the number of columns, right? So if you divide that by 2, okay, so that will give you half, right? Okay, I don't know, half. So we can now use this half in our thresh. Okay, so again, I'm going to, so it's the same code. So I'll take that code, put in here. Now instead of how equal to all, I'm going to put thresh equal to half. Okay, so if we did, if rows that have at least 50% missing, okay, so thresh half means you should have at least half of them are good. Half of them are good. Okay, then you keep. If less than half of them are good, then you're going to throw them out. So after throwing out, before throwing out, after throwing out, so the difference is 6. So we threw out 6 rows. So there were 6 rows with more than 50% missing. Okay. So this is for rows. Okay, we used drop NA mainly by rows up to this point. Drop rows with missing values, right? Filtering out missing data. So if we, here, this is where we are. We haven't come to these. Well, is null and not null we looked at. Okay, so drop NA, we've used it for rows, and next we're going to look at drop NA with axis equal to 1. We'll be looking at it each column. So we will do that next time.